Hello and welcome everybody. Our webinar today is titled How Modified Standard Gearboxes Solve Real-World Problems and What is so special about food-grade gearboxes. The show is presented today by Power Transmission Engineering, and I'm Gary Jesch, your moderator for today's webinar, coming to us from DieQua Corporation. DieQua is an innovative problem solver who provides custom gearbox solutions aimed at the trickier problems presented by freezing temperatures, corrosive contaminants, and unusual payloads. And today we have two industry thought leaders on our panel from DieQua. Before we introduce them, let me share a couple of important things with you. First, we plan a Q&A section at the end of the presentation, and you can submit your questions at any time by using the GoToWebinar control panel. We'll do our best to answer all your questions. If something does come up afterwards, you're certainly welcome to contact DieQua. We'll be happy to help. And we will provide that contact info later in the webinar. Second, a video recording of this talk will be available online in about 24 hours via our PTE website at powertransmission.com. We'll be sending out a link when it's ready, and you're welcome to watch it anytime or share it with a friend. So now about our presenters today. Hitesh Patel has a degree in mechanical engineering from the University of Illinois at Chicago. With 14 years of various experience throughout different industries, Hitesh started working with DieQua straight out of college as a product support specialist. 12 years later, Hitesh returned to DieQua, this time as a product manager for power transmission components. Hitesh currently works with inside and outside sales for defining and planning product enhancements and developments for both current and new products. In addition to this, he also helps mapping strategic goals with our distributors, OEMs, and system integrators for business growth. So hi, Hitesh. It's great to have you make some time to put this program together and share it with us today.
Hi, Gary. Hello, everyone.
Thank you so much for being on board with us, Hitesh. I'm looking forward to your presentation today. Our other guest is Michael Quas. He's the president and co-owner of DieQua Corporation. Michael's a degreed mechanical engineer from the University of Illinois. He's a second generation owner of DieQua and has been serving as president since 1998. He's also active on a daily basis on the engineering and sales floor and is always working with customers, creating engineered solutions to a constant stream of power transmission applications. Micah, how are you doing there today?
I'm doing really well, Gary. Thanks for the intro, and hello everybody. And I must say we are looking forward to talking a little bit about all the different things that we do in terms of food grade gearboxes. Can be a relatively complicated environment. So we're looking forward to getting this material out to everybody.
Absolutely, and it's great to be back with DieQua for another one of your excellent webinars. Good to have you again. Thank you. So, gentlemen, if you're ready, let's go ahead and get started. What is important for us to know about the use of gearboxes in the food grade industry?
Hello, everyone. Thank you for that introduction, Gary. We have a lot of detailed work here, so let's just jump right in. The food industry is a complex collective of diverse businesses that supply most of the food consumed by the world. The term food grade industries covers a series of industrial activities directed at the processing, conversion, preparation, preservation, and packaging of food. Because of these processes, the gearbox plays an important role as a power transmission component. Food preparation can be simple or quite complex. Therefore, we'll discuss the options available here at DieQua. We'll also have some real-world applications for you. We'll go over who DieQua is and our capabilities, and we'll leave some room for Q&As at the end. Food industry is very unique and, quite honestly, very vast in so many ways. The processes are different for the way that food is produced, whether it's milk that goes into cartons, pasta that goes into boxes or bags, beer that gets put into bottles or cans. No matter what the application is, there are regulations and standards associated with each of the processes. These are controlled and monitored by the following standards and agencies. Of course, there are many more, but we wanted to highlight a few of them here. Our job as gearbox manufacturer is to understand what these standards are so then we can make the appropriate modifications to build product to meet these standards. That means we have to create our product to withstand certain environments. It usually has to do with caustic chemicals to keep boxes sanitary, not necessarily clean, but sanitary to a point where you're killing pathogens. High pressure washes has to do keeping the equipment clean of debris. Both have their challenges as it relates to the design of the gearbox. The caustic will eat away at the housing, so depending on where it's located, you can go with a stainless steel housing, or you can do a white epoxy food grade paint. And the high pressure has an effect because it penetrates the seal. Seal is between the shaft and the housing. If an improper seal is designed, then the contaminants will get into the gearbox and it will fail, and or the oil or lubricant will leak outside. The highest degree of protection here would be a Viton seal, Viton O-ring, and any rotating member component to be Viton, because it's high, excellent capability to withstand high pressure and chemicals. Here's a chart, a lubrication chart. And here at DieQua, all of our lubricants are H1 lubricants right out the door. We are partnered with Lubriplate, aka the Fisk Brothers Refining Company, and now made all of our gearboxes NSF H1 standard. The approval and compliance was the past responsibility of USDA, but now the NSF has basically adopted the DINT standard as its own guideline. They kept the same food grade designations, therefore you still see H1, H2, H3. Here's a chart for the complexity of the gearbox. As the gearbox design becomes more complex and the degree of protection increases, of course there's a cost associated with that. But here we're going to be showing you some real world examples coming up, and a gearbox doesn't always have to be very costly. It really depends on where it is in the line of the process, whether it's in the beginning stages where it's the raw form, or towards the end where it's packaging. So it does make a difference, and we do have several options. And now I'll hand it over to Michael, who will go over those real world applications for you.
Yeah, I just also wanted to recap just real briefly on lubricants. When you go into the food grade world, there is a very specific series of specifications for what type of lubricants can be used. The type of lubricants that you typically see in industry, which are mineral based, or like a polyglycol based synthetic, or some of those, they're not necessarily appropriate for the food grade industry, or the food, for the food industry. And the H1, H2, H3 is our various degrees of acceptability, if you will. I mean, the closer you get to the food, the higher the grade has to be on the oil, so that you limit the toxicity, if you will, of any kind of contaminant of oil that may come in contact with food. So I just wanted to kind of go over that real quick. Hitesh did kind of bring up the fact that these gearboxes can be relatively straightforward and relatively easy to modify to make them appropriate for a food grade application. And it goes all the way up the chain to an all stainless, much more complicated design, depending on the environment and depending on really what it is we are trying to accomplish with that box. So what we're going to do right now is just kind of go through a couple of quick examples. The one that's on your screen right now is one that we did. It's actually in the meat packing industry. This is a particular product that's part of the main drive for the gearbox, but it doesn't necessarily have to be stainless because it's not real close to the actual food. It's part of the main drive line, but because the whole machine has to get washed down, there's a certain level of protection that the gearbox must have. So in this case, we have, I forget what's on the next slide. Yeah, what we have here is a gearbox where several things had to take place. One, we had some space constraints. So the because it was down inside the cabinet and the motor was relatively large, it had to fit in a certain footprint. So in this case, we had to modify the input of this particular gearbox. So it had to be made shorter. So we redesigned the casting, we made the shaft a little bit shorter, we changed the bearing setup internally in the gearbox to make it fit properly. Secondly, we needed to, and this is a drawing actually of what that thing turned out to be. Next slide. The two other things that we did to this particular gearbox to make it compliant was an FDA white epoxy. So there is a specific coating that is approved by the Food and Drug Administration, particular white epoxy. We use it quite often here in some of these simpler applications, and you can see it's white. And secondly, it obviously had to have a food grade oil in it. So we, in this case, used a H1 NSA standard H1 oil, not a grease in this case. And that's what the box was filled. And you'll also notice that this has a standard seal in it. Viton seal wasn't required here because this box doesn't see high pressure washdown. So let's, the next one we're gonna start talking about another example where we have a spiral bevel application. This one's going to get a little bit more complicated in the sense that it does require some stainless steel and it does require a higher degree of protection from high pressure washdown environments. Next slide, please. So I think this is a good place to kind of introduce what are called IP ratings. Now, IP ratings exist not exclusively to the food world. They actually exist throughout the industry when we're talking about mechanical power transmission. And IP ratings have to do with the degree of protection that the box must have. And so the higher you go in the rating, the more protection or the more robust the seal area and certain other areas need to be on the box to keep the oil in and keep debris out. So we're gonna, the next slide I think actually shows the actual chart. So there's two numbers associated with the rating. And the first one is kind of talking about more or less a dust protection or the ability to kind of seal the box. The second number talks about the ability of the gearbox to withstand certain types of fluids that are going to come in contact with the seal and the severity of which those fluids are going to hit the seal. When you go into the IP 67 and 68 numbers, you're actually talking about gearboxes that could be either submerged for a short period of time or submerged constantly. And submerged doesn't necessarily mean in water. It could be in other types of fluids or chemicals or what have you. And in those situations, we actually have to be very conscious of the fact that there can be no air inside the gearbox. So if there's a pressure differential, we take that into consideration by not having any air inside the gearbox. So they're usually completely filled. And in the case of an IP68, those are scenarios where we sometimes have to reverse the seals. So if this goes a little bit deeper into water, for instance, you get a higher pressure, you're actually trying to keep the water out of the gearbox as opposed to keeping the oil in the gearbox. So there's different seal configurations to satisfy the different types of IP ratings. The highest IP rating that we typically come across is IP69K. And I think that's, and we're going to show that how we solve that problem in just a moment, because IP69K is talking about, and we don't have it actually on that IP, yeah, it's shown there, but this is a very high pressure water, high temperature water, and also very often there are caustic chemicals that are associated with the sanitation of that particular machine, or in the gearbox and driveline and all the components on the machine. So this is the most extreme protection that we need to prepare and design a gearbox for. So as we go forward, typically when we go into gearboxes that have to withstand, caustic scenarios, then we have to be very conscious of what is the housing material. And this is actually showing a spiral bevel gearbox where we are an all stainless configuration. That's generally the most expensive design option that folks will typically have to be confronted with. And also, you generally do not want any kind of cavities or areas on the outside of gearbox where liquid can pool. Because if liquid can pool, that means a pathogen has the ability to grow. So in all stainless products, we generally don't put mounting holes on all sides of the gearbox, which is typical on a standard gearbox, but we only put those mounting holes on those surfaces where they actually need to be in order to mount the gearbox to the frame or somehow attach it to the machine. So these are kind of things that we all kind of ferret out prior to coming up with the final design, and this is just kind of a typical drawing of that. And I think the next slide. So we had a kind of a very interesting application. This goes back a few years. It was one that I personally worked on. It was a little bit more complicated, and we'll have a slide a little later on in the presentation, which also shows some other elements that we needed to add to this. But if you take a look kind of at the seal area, you'll notice that you don't see any kind of rubber, and that's because there is a stainless steel shield that is pressed onto the shaft that rotates with the shaft. And the end plate has a slight groove cut into it that cover kind of fits into. So it solves two problems. One, it mechanically protects the seal. So if somebody were to take a high pressure wash wand, if you will, and they're shooting at, I don't know, 1500 PSI or 2000 or 3000 PSI, and they're only a few inches away from the seal, if that seal didn't have a mechanical protection on it, it would blast right through the seal and the gearbox would fail. So this actually protects the seal. So there's a mechanical shield there, and also as that shaft spins, it acts as a slinger, so that if there's any kind of debris or liquid or whatever in that seal area, it is thrown away using kind of a centrifugal force, if you will. Other elements of this particular gearbox comes into play from a cost scenario. The last slide that Hitesh talked about was relatively not so complex gearboxes are less expensive. Certainly the more complex, more complex and more stainless oriented gearboxes get more expensive. This is going towards the higher range because this particular gearbox has a stainless steel through shaft. The end plates are stainless. The pinion is not stainless because we want a one-piece pinion. That's the strongest pinion design. And then the part that's coming out of the gearbox is actually hard chromed to protect it. It's a steel, but it's hard chromed, so it's impervious to the caustic washdown. All of the rest of the components are stainless steel, with the exception of the housing. To make the housing out of stainless for this customer was cost prohibitive. So we made the housing out of cast iron, but it goes through a painting process later, and we did various iterations of this with this particular customer. And currently we're using it's what's called a steel-it paint. It's got stainless steel impregnated in a two-part urethane formulation, so that it really gives a very high degree of protection to the cast iron element of the housing here. So this was a highly customized a gearbox. It has the highest protection rating, as you can see here, as an IP69. It includes an H1 standard lubricant because this is actually used in beer and beverage industry. This is the main drive gearbox for filling machines. These are machines that, that's actually as a bottle enters it, that goes on a large rotating machine that fills the bottle, and then the bottle exits full and gets capped and so on. And this is the main drive for that. So this thing is constantly exposed to, in this case, beer, soap, caustic materials, and it has to withstand that long term. So that was actually a pretty cool application. The final application that we want to go into some detail with is in the world of automation, which we're seeing more and more and more of. So there's really two major elements that we see out there. There's the standard PT world, which are using like squirrel cage motors and don't have a high degree of automation. You turn them on, they run, like conveyors or bakery equipment and things of that nature. But we're also seeing an element of our world where the machines are being asked to be very flexible. So there's a high degree of automation that is now coming into the industry. And with automation are gearboxes that have to be servo driven, which is a little bit different. And this happens to be a servo worm gearbox. Next slide. Yeah, this was an application for this also meat, but this was in the world where you are taking carcasses and you are carving them up to just prior to packaging so that they can be packaged appropriately so they show up in your grocery store, right? So this is kind of the butcher shop, but these are highly automated machines. No humans are involved in the carving up of the carcasses. It's all robotic. And in this case, there were a whole bunch of design elements that we needed to take into consideration. The kind of the animated portion of this particular slide on the right shows kind of a cross section of the gearbox. And the reason that we showed that is because the motor for this is a servo motor and it runs hot. And we needed to keep that heat away from the gearbox. So we introduced a zero backlash bellow coupling to isolate that heat, to keep it away. And as we go to the next slide, oh, let's go back one. I'm sorry, Hitesh, thank you. Yeah, we also needed to physically put it farther away. So there were some spacers that we needed to design, and they were made out of stainless steel. Generally speaking, this is a gearbox that's got an aluminum housing. Aluminum is a relatively robust material, but it just kind of depends on what the cleaning process is and what kind of chemicals and so forth that are going to come in contact with this particular material. And for this customer, it didn't need to be anything more complicated than aluminum, so they didn't require stainless steel per se. And we'll show some real pictures of the application in just a moment. So this is one of the spacers that we made for it, just to kind of create some more distance between the motor and the gearbox for heat issues. This is typically how we work with customers. So we make the design. There's a full up drawing that 2D, 3D, and then usually we'll work with CAD, 3D CAD drawings for customers so they can automatically put it into their equipment. We have one issue with this customer is as they were kind of going through the whole prototyping phase of getting this machine to run, they constantly had to take the motors on and off. And what they noticed is that with the bellow coupling, that was arduous, that was a problem for them. So in this case, we were able to switch that out to a different type of coupling. It's another kind of coupling that we have, which is a elastomer coupling. That's the one on the right. With that blue insert. And the reason why it was still appropriate is because it's still zero backlash. So they were still able to use a servo for positioning and accuracy, but it's much easier to take on and off. You just pull it out and the jaw coupling comes apart. So it's just another little trick that we use to kind of solve a problem. So here's a couple of photos of what this thing actually looks like in the real world. What's kind of interesting to note here, in the servo world, there are very, very few servo motors that are all stainless. So you'll see that blue bag, and that blue bag is actually what's covering the servo motor. And that's how they have to clean this machine. So they have to kind of protect the electronics using that kind of technology, because all stainless servo motors are fairly rare. We did some other things unique to this box. It had a stainless through shaft because we had some overhang load that we needed to make sure that we were able to accommodate. And in the center picture, you kind of see a little canister that's sitting on top of the gearbox. That is a stainless steel bladder. I'm going to go into a little bit more detail on that a little bit later in the presentation, because I'm going to come back to that stainless bevel box where the final solution actually had a couple of those bladders on. We'll mention that in a moment. Where are we at here, Hitesh? Okay, I'm going to switch. So those were a couple of quick examples of things that we did to solve some problems. I'm going to hand the presentation back over to Hitesh for a couple of slides, and then we're gonna wrap on a couple of other examples that we've done.
Thank you, Michael. DieQua is located just 30 miles west of Chicago. We have a lot of gearboxes to choose from. They're all modifiable for food grade type applications. Planetary, spiral bevels, screw jacks, couplings. That's where our advantage comes to play here, because we have a lot of options from gearboxes to couplings to gear motors. What we can do here is we can combine it for an optimal solution for a customer, whether it's adding a gearbox to a coupling or taking a gearbox and attaching another gearbox. We call it a Frankenstein gearbox, and that's becoming a custom solution for a customer. So because of our vast portfolio of customs, Michael's going to share a few custom designs that we have done in the past.
So yeah, this is just a couple of other quick examples of what's possible, right? So the green gearbox that you see there is just there's nothing super special other than the coating itself. That was something that was required from the customer, that they needed a very special environment. They wanted a special color that was associated with their company. So the solution was to find a type of enamel, in this case, multiple coat enamel. There was a specific paint spec associated with it, and we have our own paint booth here, so we're capable of doing those kinds of coatings. The next example on the B there is one of those Franken boxes that Hitesh had alluded to, and we do this quite often. This particular one is it's got a robot flange on it, so that's also a servo worm gearbox, but as an input with a planetary, because we needed to do a fairly compact but a high reduction in a small space. That centerpiece is on the gearbox with a large bore through the middle. That's called a robot flange. Actually, this box is then flipped over so that that hollow bore goes vertical, goes up and down. And then it's used as a turntable, if you will. So it's part of a processing machine where it goes from station to station to station, and then those stations can be reconfigured, if you will, or stations can be skipped, and hence you have a servo input, so you can very quickly reprogram that turntable to function in a different way. So this was how we solved that particular issue. We're going back real quickly right now. This is one of the prototypes that we did for that stainless gearbox solution that I told you before. But those bladders that you see on here, those are stainless bladders. They're connected to the gearbox with stainless hardware. Those bladders are also pressure differentiators, or pressure differentials, if you will. They're pressure balancers. I can't think of the right words here. Those are pressure balancers. The box is sealed, because very often in a food grade environment where there's a lot of liquids being used or what have you, you cannot have a box with a breather, because you don't want that to be an ingress point of liquid or contaminants getting into the box. That being said, very often during the sanitation process, they may bake the room or bake the piece of equipment up to 150 degrees C to kill off pathogens. But when you do that, obviously the pressure goes up in the box, and then when it cools down again, you basically create a vacuum, and any debris would come right through the seals. And so we solved that problem by putting these pressure balancers on there. So the box always remains at constant pressure on the inside, and the bladders take up the differential in pressure. So that's kind of a simple way that we solve that pressure differential problem and keep the box sealed. This is just another example of these were gearboxes where weight was a consideration. These are actually all aluminum gearboxes, but they have a special treatment to the aluminum housing called Tanox. Tanox is, in essence, it's like a case hardening process, and what it does is it makes the surface of the gearbox impervious. It hardens it, if you will, so it does not corrode, it doesn't pit. And it makes the and it's an alternative to stainless steel, right? It's a less expensive alternative. And you can see here also the screw heads are not socketed cap screws, which have wells in them, so you can put an Allen wrench in. And then there's a couple of holes in the boxes there, and the customer then would plug those holes. So this box becomes, in essence, something where when it gets wet, it cannot hold any liquid in any place. It doesn't pool. It just drains away. And it's also an example you can see on the side of the housing. There are 4 holes, and those are just the only holes that are in the side of the housing for how they attach the box to the frame of the machine. So that's just an example of how we've done. Also, custom output shaft are a little bit longer, and so on. This is another example of a servo, but this is not a high performance servo in the sense of very low backlash. It's a standard industrial. It has a stainless input flange, and it has a stainless steel custom output shaft to it. That was a relatively low cost modification. This one was a little bit interesting. This was actually a company out of Europe that was trying to get a foothold in the United States. They are what we did was the main drive gearbox is the one that you can kind of see in the photo, but behind it is their extruder, and they would. This is a company that turns. This is a company that turns that extracts oil from various nuts and seeds. So, you know, getting the oil out of walnuts, or making sesame oil or pumpkin oil. So we needed a drive machine for that. So in this case, we actually made the frame. There's a stainless steel shroud for how this thing is driven. This is also a type of epoxy paint that we used here. Again, H1 lubricants and so on. So it was just something that we did special for these guys. And then this one, although it's not the most ideal photo, this is another quick example of a spiral bevel box where the input was completely modified, in the sense that this is not driven with a motor, but this goes into, there's some kind of drive mechanism that attaches to the faces that you see that are pointing at you in this slide. And then once it is assembled, there are absolutely all smooth surfaces everywhere. So again, this is to accommodate a high caustic washdown kind of environment. Quickly also, usually in very high speed applications, heat is an issue. And so here we're just kind of showing a couple of different ways that we can remove heat, excuse me, in a particular application. The first one is not that common in the food world, just because, as you can see, you know, debris and water can kind of collect in those fins, but this is just part of a collection of things that are available to us. So those are like radiating fins. The second one, instead of having brass fittings, it would all be stainless steel fittings, and this is a oil injection system into the bearings and into the lube, into the gear mesh. The oil is drained out again through stainless porting. It is cooled and re-injected. And then the third one is basically a water jacket. So you know, again, instead of brass fittings, you use stainless fittings, and you'd flow cold water through it to pull the heat out of a gearbox. So these are kind of some ancillary designs that we do to the outside of the box to make them appropriate given the scenario. Okay, I'm going to turn it back to Hitesh.
Yeah, so this is just, we're making modifications to a particular box where we're more or less at the limits of the gearbox. We want to test the internal components to make sure they're sufficiently strong enough. And we run this finite element analysis tool to find out the weak points and modify the internal components that are necessary. For example, you know, we change out the bearings or make the gearbox more robust when we increase the size of the tooth. These are the tools that we have at our disposal when we're designing custom gearboxes that are to their limits. There's a lot of data here in this chart. The most important to note is, you know, that we went through a lot of effort to determine the range of the different greases, the different type of oils, both mineral and synthetic, and then now they're all at DieQua for NSF H1 rated. And we worked with our supplier to specifically formulate each one and each type of gearbox to maximize its ratings. You know, and this is where we start as a company, as when we had done our research to have everything that goes out the door as NSF H1 lubricated. We spoke about some of the housing materials earlier, you know, stainless steel, nickel plating. These are just some of the options available at DieQua. And, you know, these are some paint options, and I want to specifically point out the acoustic paint. We've done that in the past, and we're doing that now. It actually works. It's a paint that you spray on afterwards, and it does reduce the decibel, the noise level that's coming out. And the other one that I kind of wanted to point out, you know, because of the times that we're in now, the antimicrobial, it resists. You paint it on, and then it basically reduces, or it doesn't attract microbes, you know, fungi, bacterial, and viruses on the surfaces of the gearboxes. And I'll hand it back to Michael for a recap of.
Yeah, so just in summary, what we just really want you to walk away with here is an understanding that, you know, food grade is not necessarily an all stainless type gearbox. There's a huge range of different things that can be done to make it appropriate for the food environment, and it very much depends on where this particular gearbox would be in the process. So if it gets real close to where the food is, you're going to be, you know, more in the full stainless steel range. But if you're in a conveyor, or you're, you know, in the packaging after something's already been, you know, put into a, you know, you're putting multiple containers into a box, for instance, it's still in a food grade environment. We still have to take into consideration cleanliness. But it doesn't have to be all stainless. So there's really a big variety of different things that are possible. And you need to pay attention to the seals. You need to pay attention to the housing materials. You need to pay attention to the coatings. And those are just the outside from the standpoint of keeping the box clean. And then on top of that, obviously it has to work for what you need to do. So the configuration, the orientation of the gears, what kind of technology is going to be best for a particular application. And we tried to kind of show some of that variety in some of the examples that we put in front of you. And then, of course, the degree of protection, the IP ratings, which is something that we also kind of touched on. So I think that was it, right?
Yeah.
I hope that everybody, you know, got something out of the presentation. We went through it relatively quick. There was a lot of information there. And I think we're probably at a point right now, Gary, where we, you know, can take some questions.
Great, Michael and Hitesh. Really an informative presentation. There's a lot going on in the food industry right now. While we're waiting for people to come in, and you can go ahead and send us your questions via the questions tab on your GoToWebinar control panel. Just type those in, and we'll make sure that we get those over to the guys here. But you know, that's a bigger industry than a lot of people realize. How much of a market share does DieQua have in that industry?
Oh, that's a very good question. You know, we're not a huge volume supplier, and I think you can discern from, you know, many of the slides that we went through, where the market's immense, right? So you're talking hundreds of millions of dollars are spent every year on just the power transmission side of the machines used in the food industry, because it's a huge industry. Where we come into play and where we shine is in those more complicated, more difficult types of applications. And so we have a lot of different technologies that we can throw at, you know, throw at a particular problem or a particular issue that a design engineer may have. So, you know, we do, you know, several $1 million every year, obviously, in the different types of gearboxes that we sell, but we're more of a niche player, if you will, in that industry.
Well, it sounds like a great contribution. We have a question here for you, Michael, about the acoustic paint. Our attendee says, what dB reduction can you get with acoustic paint application?
A little bit depends on the type of gearbox and the speed and the load. You know, very often in just a regular standard gearbox, when you're at relatively high speed and approaching the limits of the box in terms of torque, the noise is higher. When we apply generally this acoustic coating, we drop the dB rating anywhere from 2 to 8 decibels, depending on, you know, how that gearbox is running. We had, it's not a food application, we had recently another application for a customer that is making a very unique product where furniture actually is lifted and lowered out of a ceiling. It's for an architectural firm, and in that case, everything had to be dead silent. And so these were planetary gearboxes that we used this coating on to solve that problem, so that when it's lifting and lowering, the people in the room hear nothing.
Yeah, I remember in one of our previous webinars, you were telling us about a turntable gearbox on a stage in a theater, right? And
Similar, exactly.
yeah.
A lot of the theater type applications are always looking for, you know, gearboxes to be as quiet as possible. I mean, if you're at a rock concert or something like that, it's not as critical because it's crazy loud anyway. But if you're in a play or a symphonic type of environment, you don't want any ancillary noise.
Exactly. Okay, we've got another question here for you. First of all, one of our friends out here asked if the webinar will be available online, and yes, we're recording it now, and we'll be putting it up on the powertransmission.com website in about 24 hours so that you'll be able to check it out. And as far as Scott, your question about getting a presentation that you can send out to customers to review DieQua's capabilities, what I would recommend, and Michael, you can weigh in on this, why don't you, Scott, get in touch with Hitesh or Michael after the slideshow or after the webinar is over, and let them know just exactly what you need, what you're trying to communicate, and I'm sure that you'll get the help you need. Is that right, Mike?
Yeah, it's absolutely right, Gary. We just threw the slide up that has our contact information. So our website, obviously, you can get to us. There's my email address, Hitesh's email address, our phone numbers. You know, whatever mechanism is most convenient to communicate with us, we'd be happy to work with anyone.
Yeah, you bet. There's good question, Scott. Thank you. Another one, Mike. Are there smaller servo, like it looks like in the range of 60 millimeter frame inline planetary, for example? Smaller servo gearbox options for washdown food grade application?
Yes, there is a number of planetary gearboxes that we have in all stainless housing configurations and stainless output shafts. The input may not be stainless, but it doesn't have to be because it's enclosed. But yeah, absolutely. We have, there's really quite a variety of the types of gearboxes that we offer from the standpoint of spiral bevel. You have inline planetaries. We have worm gearboxes. There's a series of helical products, all of which can be produced in all stainless configurations.
There you go. And I see Hitesh has flipped right over to some of the sections of the DieQua catalog there.
Correct.
To
Yeah, actually, there is a stainless planetary right on it's on the right side. It's the top grouping of the planetaries. The center one is an all stainless box, for example.
well, there you go. There you go.
A lot more choices, but these were just some of the highlights within that category of the products. So obviously with our website, there's
a ton more.
Yeah.
There you go. Yeah, a ton more, no doubt. So overall, then, does DieQua do more, I guess, what you'd call commodity or custom solutions?
We obviously do both. You know, we certainly appreciate the higher volume standard product without question. But I would say in the neighborhood of 60-ish% of everything that leaves our dock has some element of customization to it. You know, be it a seal bearing inside or some kind of special input or output configuration or some component, all the way to you know, a complete custom gearbox that doesn't look like anything else that we have. So yeah, we do a lot of, we do about 60% of our volume in some form of customization.
And what would you say is the biggest custom job application you've been faced with, and what was the solution?
Well, the one that I showed, which was for me, I've used this example, you know, one or two other times over the years. That was that spiral bevel gearbox that was it was actually a bottle filling application, and that one took a little while to figure out. We had gearboxes coming back to us that would last about 12 weeks, and then they'd be destroyed. And we'd get them back, and obviously 12 weeks prior, we'd ship them out. They'd look pristine. We'd get them back, and they look like a truck drove over them. I mean, they're completely corroded. They were we didn't want to open the gearboxes inside because they stunk to high heaven when you opened them up, because there was so much debris, not debris, but the oil had fouled on the inside because a lot of material got into the gearbox. It was just a nasty thing. And it took us a little while to figure out the dynamics of what was going on. Even the customer was playing around with different seals and put a lot of effort into it. And I had the opportunity to go visit the customer on 2 different occasions to kind of figure out what the problem was. And that's where that whole pressure differential bladder solution kind of came into play. That was the first step at solving the problem. And then the second step was creating the gearbox so that it would not corrode so heavily. And then we had to play with it from a sense of cost. You know, if we made it completely out of stainless, you're talking about a 3-time cost factor over a standard box. And most customers don't want to, you know, work with that kind of differential in cost. outside of if it's an edict from the FDA that it must be must be stainless. But most of the time that's not the case. So, you know, we always have to do then a hybrid of, you know, create as much stainless content and then compromise and create housing materials that are not cost prohibitive. And that was the solution that we came up with for this particular customer. And that was over the period of probably about, I would say, 6 months start to finish from when we were initially confronted with the problem to how we, you know, how long it took to figure it out, you know, together with the customer, obviously.
I bet he bought you a beer after all that too.
Well, he didn't, but it was a beer filling application. Yeah, that would have been nice. A couple of cases of beer.
Yeah, would have been nice.
Yeah.
All right. So Jan asks, how many gearboxes are you making yearly?
Oh, good question. I don't have an exact count, but it's in the multiple thousands. I mean, we're probably 10,000 plus a year of various different types, and that's increasing because it's also shifting the market. You know, we're seeing a lot more in the world of planetary because the market that's really kind of growing quickly, it's not the dominant market by any means, but it's growing quickly, is the automation world. And in that scenario, you typically have a motor gearbox for every axis. And in the power transmission world, you solve that by having a single motor, and then you use a lot of right angle gearboxes to create the different axes off of a main drive line, as an example. So it's shifting a little bit. So when we're using a gearbox on every axis, the volume goes up, but the mechanical complexity gets a little easier. So I don't know if I explained that well enough, but so we're selling more and more gearboxes and different kinds. You know, also the degree of accuracy is going up. People are wanting more precision in the types because they need to be able to predict where something's going to be. The motor's going to turn so much, and on the output, the product has to move also so much, and they need to be able to predict that. And the only way that can be done is if the gearbox is relatively precise.
All right. I have a question from Joe, and he mentions NRE. Now, I'm not sure exactly what that is, but you can probably tell me. How is NRE handled when designing a custom product for a customer? And is the NRE charges, are they required up front from the customer, or can it be amortized over the life of the program and buried into the cost of the product?
Yeah, it actually can be either way. It's just something that we negotiate with a customer, and it also depends on, you know, what those charges are. So if it's relatively straightforward, you know, you handle it with a one-time charge. If it's a little bit more complicated, we can amortize it in. You know, it's really case by case. We try to remain as flexible as possible and work with whatever works best for the customer.
And what is NRE standing for? What is NRE?
Non-reoccurring engineering charges. If I'm understanding the right acronym from the customer.
Okay, yeah, that sounds like it makes sense. Okay, thank you, Mike. I think looks like our last question for today's presentation. We're asked, what is the price difference if I took a standard product and now the requirement changes to a stainless box? What's the price difference? What should they expect?
If you're going, a rule of thumb, and this is a very broad rule of thumb, if you will, but it's usually a factor of 2.5 to 3. So if you've got a spiral bevel box that's cost, let's keep it simple, it costs you $1,000, and you need to make it all stainless with you know, all stainless components and so on, it's going to be a factor of 3. So that other gearbox is going to cost you about $3,000. And that's generally the rule of thumb that we typically see on, it doesn't really matter which style of gearbox, it's generally a factor of 2.5 to 3. And to reduce that factor, you know, that's where we come into compromise. What else can be done? Yeah, to instead of having it all, and it's usually the housing is the most expensive part. because the volumes typically aren't real high. So, most people out there in manufacturing realize that if it's low volume, onesie twosies, and you're making, a special, it's really expensive, as opposed to a standard gearbox that are, designed to be made in volume. So that's the main reason that you have those kinds of differentials.
All right. Well, I think that's gonna about do it. I do have one other. While I'm asking this, could Hitesh, could I get you to go to the final slide in your slide deck, please, with the contact information? And we'll just squeeze this last one in here, okay, Mike?
Yep.
Might as well get you folks taken care of. That's what it's all about here at DieQua. The question is, what is the quality of internal gears? We haven't really talked about that too much in this presentation. Are they shaved gears or ground gears is what our attendee is asking.
They are typically all ground. Depends a little bit on the technology, right? So all of the spiral bevel gearboxes that we provide are all ground, and these are helical products. They are produced on Klingenberg machines, and they're ground, which is a relatively new technology in terms of spiral bevel. In the past, spiral bevels were very difficult to grind. They were usually case hardened and lapped as match sets. Now they are ground, and the gear quality is actually much, much higher. Most of the other products that actually all, a lot of the helical are skive hobbed, if you will. So they are hardened, they're hobbed, hardened, and then they're hobbed a second time to get to the final configuration. And then the more precise gearboxes, they're all ground. So they're hardened and ground gears. And that goes for the worm gearboxes, with the exception of the ring gear, which is a kind of bronze material. That's typically not ground. That's just processed and hobbed. But the worm is ground. All the planetary gears are ground. I'm just looking. There's various gearboxes around the room that I'm sitting in here to kind of answer that question. Spiral bevels, all of our planetary, all of our servo type gearboxes, those are all ground. So yeah, for the most part, 90+% of the gearboxes that we have, all the internal components are ground gears.
And are those is that work done in-house there, Mike, or outsourced?
It is, we work with factories all over the world. Most of them are in Europe. All the spiral bevel gearboxes come out of, all the componentry comes out of Germany, with a few exceptions. We manufacture most of the housings and end plates and shafting and that kind of component, but all of the gear sets, in this case, all are coming out of Germany. For us, we don't manufacture the gears per se, but they are produced to our specifications, if you will. And for us, that's a really kind of a nice combination, because then we don't have to invest in the equipment necessary to do that. So we take advantage of manufacturers around the world that can produce it to the quality levels that we require, and then we do the majority of the assembly. And also it allows us a lot of flexibility from the standpoint of customizing. So we have a lot of CNC equipment here where we do all of the specialty work, and the volume production are done by suppliers for us around the world.
And I know, knowing you and your company, that you're very strict when it comes to the standards and the quality of these components that you're getting from other sources, right?
Yeah, absolutely. I mean, the only thing that we have is our reputation, right? So we do not compromise. I don't go to various countries out there where the quality levels are inconsistent. We really vet out the people that we work with very, very thoroughly to make sure that there's a tremendous consistency, because we have to stand behind, obviously, everything that we put out there.
Well, it's been a great talk today. Thank you for all of the excellent questions from our attendees here in the audience. We sure appreciate your engaging with us. And if you do have a question, or you're watching the webinar on demand later, please feel free to get a hold of Michael or Hitesh, and you can see that they've got their email address and phone numbers to reach out to them at a later date. We welcome that, hearing from you. And so I guess it's time now for everybody to just give our presenters a nice round of virtual applause. Thank you for sharing this knowledge on today's program. Ladies and gentlemen, Michael Quas, DieQua President, and Product Manager Hitesh Patel.
Thank you, everyone.
Thank
Nice.
you.
Thank you so much. And on behalf of Power Transmission Engineering, thanks very much for joining us and wish you all the best. Have a great day and take care.